Hello, today we are going to install the SPA program. Please note that you have to save the SPA program to a place where you have write access to a file. You may choose to save it to your desktop or your documents. Today we're going to save the program in my desktop. I actually already have the compiler runtime saved on my computer. Here you guys can just use the default pathway and just press next. And press install and the installation is finished.
So now that you have SPA installed on your computer, you can go to double click on the SPA icon on your desktop to open it up. And this is going to be the solver for the program. So this is the solver. You can see down here that there's no data imported. Just to show you, we could hit this solve button and you get an error message that says you have to load the data in. Usually what you would do is you'll come up to other and you'll download this XML file. An XML file which contains student and project data, which is integrated with work that Sean has done. But currently at this time, that piece is not completed. So we have a sample XML data that we're going to use for this demonstration. And so what we're going to do is we're going to go up to File, Import, and from .xml. And our sample data is on the desktop. So we're going to come here and load in go to sample, open. So now you see that a pop-up appears that says data is successfully loaded. And if you want to view this data that's been imported, you can go to edit. For the student data, you click on student data. So this is just sample data that we have imported. As you can see, this 9-digit student ID number, first and last name with access accounts, the student's majors. The next column denotes whether a student is intending to graduate, whether the student is willing to sign an NDA or an IPA. The sections that a student is feasible to attend, the preferences, which corresponds to project titles, and the date and time that they submitted. So another feature that this window has is that you can edit any of the existing data that's in here that you imported. To do that, you go to this cursor looking symbol, and that enables edit mode. So if you just click this symbol, now you can just click on any of the fields, and as you can see, we can enter any data if a student's name is misspelled or so we're just going to exit back out of this window here. And if you want to look at the project data, you go back up to edit, come down here and click on project data. So this loads all the project data, including the project ID, which is used in the algorithm. As you saw in the student data, the preferences correspond to these numbers. And here, this is also just sample data with just sample projects, titles, along with their sponsors, the sections that these projects, that the students who are assigned to these projects will meet. And also they have the majors that the projects require, whether the projects require a student to sign an NDA or an IPA, and also the lower bounds and upper bounds for the projects. Another capability of the SPA program is this button called Major Bounds. So if we just click on this button, Major Bounds, a new window is going to appear. And what this window is the composition on a major by major basis of each project. So we'll expand the project IDs. So for example, project number 1 is called Lean Implementation Help Team 1, and this requires at least, this one right here means that this project requires at least 1 industrial engineering major and up to 5 industrial engineering majors. And as you can see, all the rest of the majors are 0 for this project, which means that no other majors are required for this project.
So in addition to modifying the major bounds, you can also take a look at the sections and the majors in the program. Here you could select major data, and these are all of the majors that are available in that capstone class for that semester. And these are all of the sections that run for that capstone class. Now that the data is imported and we have gone through each section, we are ready to solve the algorithm. The algorithm solves very quickly since it's a small data set, and it returns no feasible solution exists. However, this was an optimization of the code. Now it returns the nearest feasible solution, and we can export this to a .csv file, and it will show every assignment student to project that was made, and then it will also tell you the ones that did not get assigned. We will export this and take a closer look. So now the Excel sheet is exported to wherever your SPA folder is. In my case, it's on the desktop, so we'll open that up. I'm just going to expand the sections a little bit so we could take a better look. So as you see, it has the student's first, last name, email, and then it goes into the project data, the sponsor, the project title, the instructor of the course that they were assigned to, and then pretty interestingly, it tells you what choice that was for the student. As you can see, only one student did not get matched. Everybody else got their first choice. There's a few second and third, and it looks like there's a 5 and a 6. In addition to this assignment, it tells you some extra information at the bottom of the Excel sheet. For instance, the project determination of the transverse rigidity of steel wire ropes is short 1 student on its overall lower bound. So that project may or may not be able to run because it's 1 short under the lower bound, so it's likely that it won't run, and you could just add 1 more student to it. Another example, Lean Implementation Help Team 1, that's a project that's also short 1 student of its lower bound. So as you can see, this was a very small data set. However, on a larger data set, you would have the additional students to throw on or off of a project, move them around a bit. And like I said, this is an upgrade from the last program. That one only returned a solution if it was feasible. So this is a pretty good feature of this program. So another useful thing about this program is upon closing the project assignment solver, the data gets exported to a .mat file wherever your SPA folder is. In our case, it's on the desktop. So you'll see a .mat file appear on the desktop after I close this window. And here's the data.mat file. It was saved from the last run. So if we go back into the program, we can open up that data.mat file by importing from .mat. And there's the same data. This is useful because you can actually edit the data within the solver and then save it, so you don't have to keep editing within Excel or something like that. So as a continuation, I'd like to talk about another common error that could occur. As you can see, the project Lean Implementation Help Team 1, there is a non-zero major lower bound for a major, but it's not in the major list. So what that means is on the project, somebody entered major bounds on a major that actually wasn't applicable to the project. So if we look at lean implementation team 1, you could see that there's 2 CompSci lower bounds and 2 CompSci upper bounds. However, CompSci doesn't appear in the majors list, so that's an error. If we change this, the project should run appropriately. And then again, we have to press save and exit for the changes to be reflected. And the algorithm solves and can be exported to an Excel sheet. Okay, so now I'd like to demonstrate the error checking capabilities of the tool. If we press solve and there's something wrong initially with the data, you will be warned that there's an error. For instance, here the project auto barcode reader system, the sum of the major lower bounds exceeds the overall upper bound. As you could imagine, that could be a problem. So we could actually change this right here on the solver and then rerun the data. If we go to project data, major bounds, you could see that for the auto barcode, the lower bound is 4, and if we check out the overall upper bound, you see that it's 3. So right there you have a contradiction, so we're going to lower this to be no greater than 3, and then the solver will run. And then to save and exit, you go to File, Save, and then the data will be reflected when you press Solve on the solver. So now, as you can see, we have a solution. Okay, so we have created some mock data to show the powerfulness of the tool's suggestions that it makes. So we are going to press Solve. And it says no feasible solution exists, nearest optimal solution was found. So let's see what it says. Okay, so it looks like a few students got random data. That's because we didn't look too carefully into matching students and their majors exactly with projects, although this is handmade. There's one student who's not matched. However, at the bottom it's telling us that the project determination of the transverse rigidity of steel wire ropes is one student short of its overall lower bound. And since this data is mocked, I know that that is because Colleen is not in that section fit for it. So if Colleen, for instance, decides to drop that class to get into this project, we could modify that in her student data, and then this will return the feasible solution that we were looking for. So let's make that change. So just to show you what's going on, that project right here is actually in the section of ESC 497. And Colleen is in that major, however, her schedule conflicts with that section. So the only schedule Colleen can attend is CompSci 483W. However, let's say she drops a class and then she can miraculously get in, and we'll make that change here. So now it's ESC 497A, so she can attend that class, and as you see, 5 is a preference of hers. So now instead of not being assigned to any project, she'll go to that project that needs one more student. So if we press save and exit and then resolve this, there we go, we have the blue check mark. The optimal solution is found. So let's export that, and then you'll see that everybody is assigned to one project and exactly one project, and there's no suggestions because everybody is assigned. Okay.